Welcome to our session, IoT Native with Spring Boot 3. So today, Stéphane and I, we're going to talk about the work we've been doing these last few months and years, and the current state of things about everything IoT and GraalVM Native.
All right, so a bit of an agenda. We will start by explaining the basic concept of what GraalVM is and what does native compilation actually do. So this will be relatively independent of Spring, so that the base concept will up to speed. Then we will build our first native application, which will be a follow-up of what you've been seeing at the keynote. Based on this, we will go into more details of what the Spring integration entails, and we will continue with the developer cookbook. So essentially, giving you steps that you can take on your existing application to validate or to check if they're native ready, or if perhaps, surely, there's still some stuff on our side to fix. We'll end up with Q&A, and I want also to say that we are monitoring actively the Spring IO app. So if you have a question after, or if you prefer to ask the question asynchronously, we'll look at that after the talk.
So about GraalVM native compilation, so first what we want to say is that GraalVM itself is a huge piece of engineering and a tremendous effort from the GraalVM team. So during that talk, we're going to talk about GraalVM native compilation, but we just wanted to highlight that GraalVM is doing way much more with a specific, like a very optimized JIT with its JVM. It's also supporting many languages running on the JVM, and even languages talking to each other and so on. So there are many features in the GraalVM space, but today we're really focusing on the native compilation and how that will relate to Spring Boot 3 and Spring Framework 6. So when we're talking about native compilation, we try to summarize what are the current features and challenges. So on the features side, what we're seeing is that with the GraalVM engineering, we're basically getting memory efficiency at the megabytes and the megabytes ballpark. Startup time, milliseconds. And when we're going to show you those results with a compiled Spring application, this is like not the Spring engineering efforts on its own. It's just GraalVM native doing a lot of work. What you can do with it is you can do many things. So it's well suited for a bunch of applications and a bunch of types like CLIs and function and scale to zero scenarios, which might not be a typical use case for JVM applications, but you can also compete in places and in spaces where usually Java was a bit not even considered. So now when you have applications in Golang, Node.js, and so on, their territory basically, you can also reach there and compete. But the thing that seems to interest a lot of the community, a big part of the community, is container density. So when you're deploying a lot of microservices, a lot of apps on your infrastructure, you're looking at your VMs and hosts, and you're thinking, there's a lot of gigabytes being taken by the VM, so I'd like to maybe densify all that and use my memory a bit more efficiently. So that's one thing to keep in mind.
But that doesn't come for free, of course, otherwise that would be too easy. There's some additional configuration that might be required. As you'll see, GraalVM does a static analysis of your application, and something it can infer, a lot of things it can infer, and some it can't. And for those cases, you will have to provide additional configuration, and we'll show you how you can do so with the Spring Framework. Something to notice also is if you have high traffic, you won't get the same peak performance as a traditional JVM. Talking about developer experience and debugging, especially some specific tool will be required. It's not like your story of firing up the IDE yet. Maybe that will change, but at this stage, it's not the case. You can fire up the IDE in debug mode and just like breakpoints and whatnot. That's a bit more complicated than that. Also, there's no Java agent support, and there will probably never be. Someone was asking at a session earlier on OpenTelemetry if the OpenTelemetry agent would work with a native deployment. Unfortunately, the answer to that is no. And not all JVM vendors support it. So you may have a support contract with a JVM vendor that does not support GraalVM yet.
Right. So we want to give you a really quick and crash course to GraalVM native compilation, just to give you like orientation and so that you understand the basics. So this is an oversimplification, but you'll still get the basics and you'll understand enough things. So when you use the native image binary, so this is a binary that comes with the GraalVM distribution, this binary will compile your Java application into a single binary file executable for your target deployment architecture, CPU. So what it does, it's got basically several phases. The first one is about processing all classes. So looking at a fixed class path during build time, it'll look at all classes, start analyzing them. And then next stage, it will perform static analysis. So basically looking at your Java syntax tree and deciding what it can be resolved to a constant, what is the flow of the code, what can be executed at runtime, what will be reached at runtime, and so on. And for cases where static analysis cannot decide if the code will be picked up or not at runtime, depending on external conditions, you'll need to help it by adding reachability metadata, basically telling the analysis engine that this class will use reflection on this class at runtime, that will need some resource on the class path at runtime for cases where the engine basically cannot know. And once that is done, all the analysis is performed, then it's compiling everything, all the reachable code, all those classes, compiling everything into a single native image. So that's code and data into a single binary. And that's what you can execute on your target deployment.
So this is an example where actually it wouldn't work so well in a native image without some hints. So this is a case where typically what a framework would do, where you give it a service, then we need to find something that would declare a stereotype. So in this case, a destroy method. Then if that method exists, we would invoke it at typically context shutdown in this case. The problem here is the service.class, service.get class rather, if GraalVM cannot infer that to be a constant, it will never be able to know which class it is, won't be able to inline, and so it won't be able to know on which class it will need to add a reflection information essentially. So if you run that code on the JVM, obviously that would work, I mean, considering there is no issue in the code. But if you compile that to a native image, you'll see that your method will not be invoked at all. So to alleviate that, what GraalVM provides is a set of reachability, what they call reachability metadata. So it's a way for you to provide extra context to the native image process so that it can infer the right thing. In this case, as you can see, I'm saying that the default my service needs to have special handling and that the destroy method that takes a context needs to be exposed. There is some information missing on that slide, but there is various ways you can define the hint. You could say, I want only to be able to query the metadata, but I don't need to invoke it. Or I also need to invoke it, which automatically add introspection. The reason why there is this difference is if GraalVM needs to be able to invoke a metadata in the native image, this way it needs to ship more information to the binary. There is also other types of hints that you can contribute. You can contribute hints for resources. So for instance, by default, if GraalVM does not detect a resource as being a constant, or I believe actually it doesn't at all. So if you're trying to load a file from the class path, for instance, it won't be shipped automatically in the binary image until you say so. If you want to create a JDK proxy, it won't be able to create it until you say so, because it has to ship all those information regarding reflection.
Okay, so as a framework, our job is to do things and execute code that we don't ship ourselves. So we have to work with the code that you wrote, and we're doing a lot of these things. So that's the life of a framework, basically. So there are two ways to deal with this situation, how to adapt to make things work in a native environment. The two ways are basically like this. So reachability metadata, just like Stéphane showed, we can basically contribute such metadata at any point in time before native compilation. And from that, the static analysis and the engine and so on, everything will be taken care of, and it's going to be fine. On the other hand, what we can do as well is contribute code that makes it obvious or way, way easier for the static analysis engine to figure things out without even needing extra metadata. The advantage of that second option is that the static analysis is super powerful, and it can do tree shaking. So if it realizes that some parts of the code base is not even used, it won't compile it, it won't load it, it won't be in the final image. On the other hand, generating sources or code or bytecode, whatever, it's a harder problem than writing the code directly. So we've got to find the right balance for every case. Should we have metadata? Is it easier? Is it better is it good enough for performance? Or should we generate specific code to handle the case and teach the analysis what we need to teach it? We're going to start with a first application to show you how this works.
So this is an extension of what we've shown at the keynote, so essentially a CLI where there is an extra service that says hello, and there's an implementation that just, simple, so it doesn't do much, like a hard-coded prefix. There's also a version of it that loads a file from the class path, which is at the moment here, and you can see that the prefix has some brackets in there, just to show what it's using. I also have a command line runner, which does inject object provider. So if you don't know about object provider, it's a way for you, it's a core concept in Spring that allows you to inject a dependency that might not be there, and you can, actually a collection of objects. And so that will actually provide you a way to query the bin factory for a given type. So essentially the runner, what it does, it lets you print messages based on several strategies with options that you can specify as command line arguments. The reason being that it takes like 90 seconds to build the image at the moment, and if every time we had to wait 90 seconds to show you what the outcome was, that would be pretty painful. So we put all of them in a single application. So let's actually try it out in my IDE. So I have no option provided there. So let's say, let me put, I don't know, resource, for instance, which is the hello file. And run that again. And you can see it uses the implementation that we've chosen. Okay, so it's barely from scratch, startspring.io, the few pieces of code that you've seen. So we haven't much yet. So let's first opt in for AOT and native processing.
So for that, what we're doing, we're adding the native build tools Gradle plugin. So this is a plugin provided by the GraalVM team, and that plugin will just look at your application and gather all the information and trigger the native image binary call that you need. So you could do that by yourself manually, but this is quite neat, and this is powerful because with the Spring Boot plugin, what we did is we react to the presence of this plugin, and when it's activated, we also add new tasks of our own, and we adapt. So you can just create your own application, compile to native with a single call, which is the native compile task.
So there is something that's happening when we enable this. There is this generate AOT sources, and you see a banner showing up and some logging statements, but you don't see actually the outcome of the command line runner. So this is one key of this processing. What it does, it's parsing the bin factory, working at the bin definition level, so not working on bin instances themselves, because obviously we can't actually create that at build time. So it will look essentially at your application context, your config infrastructure, essentially the post-processing that might happen on the bin factory, some of the infrastructure that you've opted into based on your environment, and then it will collect the bins that would be created if we run that again. So there was a question at Jürgen's session also about whether or not we can be sure that it would do the same thing, and there would not be a disconnect between what the runtime would and this would do. So the answer to that, or partially an answer to that, because we're not sure if we would be answering that question specifically, but what we try to do is we try to be as close as possible to what the runtime does. We actually run the same code, except that code runs in a slightly different mode, essentially. So we've processed the context, we've generated some code, so the next step is to compile that code, invoke some callbacks also as of the processing to generate the necessary hints. It's invoked not only for our implementations, so everything, as Brian explained, the parts where we don't need especially to generate code, but we could rely on reachability metadata. We have implementations of our own API that would be invoked, but also if you had use cases, as we will see later, then you can also implement that interface yourself and contribute hints so that it works in a native image.
So now, as you can see, that's the usual output for the native image compilation. So it's telling you a bunch of things about how long it took for each phase, the amount of code and memory that's contributed by each package, and so on. And once you have all of that, you're getting a native binary in the build native compile folder, and you can execute it, and you're getting the startup time that you expect. And if you check for the memory, you'd get the result that you expect as well. So yeah, so now we've got our native application, and we can try it for other cases.
Yeah. So the first case we want to try is bean, and what it does, it queries the application context, the bean factory, the way the bean factory itself would. And if there is a bean of that type, then it will use it. And actually, it turns out that we do have a bean of that type defined in this class, which is a configuration class that has been contributed by class path scanning. So everything that you're used to, right? There's nothing specific here in this config. This is like idiomatic Spring config. So if I'm providing this option with bean, we see that it works. So essentially, the message here is the first step of this engine is to make sure that everything that's related to config, bean factory processing, how you define your infrastructure, essentially, we got you covered. So we are able to infer the metadata and contribute the right thing.
So yeah, so the alternative would have been to contribute a truckload of metadata for all configuration classes, enabling reflection and invocation on a bunch of classes, basically all your configuration infrastructure, including the one from Spring Framework and Spring Boot. And in this case, code generation has yielded better results.
So the second case is to use reflection, and as you can see, it's slightly more tricky. I mean, we're not hard coding the simple hello service class. So GraalVM cannot infer which method to use. If you try that, it's actually failing because it doesn't know about simple hello service. It couldn't infer it at build time that it was required, so it didn't ship the reflection metadata in the native image, and as a result, you can't query that class.
Yeah, but inside the execution, you're getting like the usual VM behavior, so it's just not finding that resource, it's finding nothing, and you're getting the usual stack trace and the usual exception, so it's not very different from what you'd get in a regular JVM application.
The other one is resource. So resource, I didn't actually, not that it's very complicated, but the implementation, what it does on the resource abstraction, it's doing a get input stream, so essentially asking the class loader for the resource and then opening an input stream to it. And if I do that, I get, as Brian was explaining, we get the usual exception saying there's no such file on the class path.
Right. So now we need to, so we've shown that the configuration infrastructure in Spring is already covered by the AUT generation on our side. But so what we're trying to do right now is to show you what you would need to do in cases this is not covered by the Spring AUT infrastructure. So there are several ways. We're going for the simplest one, which is registering hint, so reachability metadata. In Spring Framework 6, we've added a new API, many new APIs. One of them is runtime hints and runtime hints registrar. Runtime hints is like the one-to-one image of what the GraalVM reachability metadata looks like. So there you can register reflection and resources and proxies and so on. In this case, we want to teach the analysis that we want reflection on a specific constructor for the simple hello service. And so that would take care of adding reflection for this. And also we need to find another to teach also the invocation on the actual say hello method. So two things, instantiating reflectively our service and also calling reflectively our method.
So you can see that for the sake of this example, we are actually using hard-coded reflection on a type, but specifically what will happen in a use case where you need those hints, either they're completely static and then you may not need to go that fine grain. Here we really want to show you exactly each individual thing that needs to be set. But in the case of this service, for instance, it only implements one method. So you could say, you could ask GraalVM just process all the methods, for instance. So there is a member category flag that you can use for that. But also, usually what you do is, it's more for an advanced topic for a future session, you can also browse the bean of your application context and then look at them if they implement a stereotype. So for instance, the destroy annotation we were talking about earlier, what you could do, if you had that in your custom framework, you could look over the beans, check if one of them had a method annotated with destroy. You would get a method handle as an output, and then you can just pass it on to the hints, and that would work.
So here we're adding reflection, and by itself, reflection is not bad. Some of it is more costly than other cases, but really the GraalVM team is always making progress on this, so it's really on a case-by-case basis. And here it's perfectly fine in our case. But so we've done the reflection, but we're still missing the resource case. So same thing on the same hints. For the resources, we want to register a pattern. So this will register all the resources on the class path matching this pattern will be added to the image, to the resulting image. But we've got other things like with resource bundles, and yeah.
A shortcut for type, yeah.
Yeah.
In case you need to ship the actual bytecode. Because, for instance, you may use ASM at runtime for some reason. If you do so, and you still need to do that at build time, you can't, at runtime, sorry, you can't move that to build time, then you will have to ship the bytecode in a native image. Probably something that you may want to avoid.
Yep.
So the next step is we want to make sure that that stuff is actually invoked by the AOT engine. And there is an annotation for that. And it works the same way as the regular import you'll know for configuration classes. So if that component is not included for some reason, because you may have a condition on it, or you may change your mind, or you configure it a different way in a profile or something like that, then the import will not be processed and the hints won't be contributed.
So with all that, we should have an application that works, and we can trigger again. But this time, it's going to generate different sources. So
yeah,
we can look at this.
Yeah, right.
We haven't done so. So the good thing about, so if you're using a modern build tool like Gradle, it will do a bunch of nice things. And if you're using also a modern IDE like IntelliJ, you're going to get the generated sources inside your project, and you can basically browse the generated Java code that the AOT processing from Spring did. And you can browse it, you can look at it, you can just shift-click on it to browse the entire code hierarchy. You can figure out what's going on. We also went to the trouble of generating even the Java docs because it's nice. And so yeah, this is basically something that the equivalent of what would you write in a very functional manner if you had to write the entire configuration by hand very functionally. But here, it's done for you automatically. including package visibility and all that. It's done all that for you. And what Stéphane is showing right now is that the demo application runner that we have and that we created in our configuration class, the actual instantiation and is done here for us, including arguments resolution in case some are needed and so on.
So for the reflect config, we should have something about, there we go. This has been contributed as a result of us writing that code and the AOT engine triggering it. And if we look at the resource config, whoops, I might have done something wrong there.
That looks good.
Looks good. Oh, there we go, I missed it.
Okay.
Sorry. So the GraalVM format is using regular expression, and we know how you love that. So what we've done for a start is supporting that as a pass-through, but you can also use wildcards, and we will infer the regular expression automatically. Right. So we're back. Oh yes, it took a long time, I know. Let's go back with our test. There we go, the reflection works, and the resource
Same for
works.
resource.
Okay.
So good, we've shown the couple of ways to deal with this, and now we're going to zoom a bit back and show you what really happened. So the AOT, what is really behind the AOT processing when we're talking about it? AOT processing is not an annotation processor. It's really something that happens after. So it starts with your app compiled, so your compiled sources and all the resources on the class path, and we're operating on a fixed class path basis. Then we've got tasks, so this works also on Maven, of course, but we have like a process that generates AOT sources, so that's the part where we saw the Spring banner, and when the configuration is parsed and we're generating a bunch of Java code so that the AOT version of your configuration is generated. And then we compile that code in a second pass. And once AOT is done, so you get your application, the AOT sources, the compiled sources and resources, and also the GraalVM config. So the goal is, once you have the final jar, here you get not only the sources, the classes we've contributed in the AOT build, but you also get the sources that we generated in the first place. So if you want to look at them, debug them, see what's going on, it's free, and you can look at them and understand what's going on. From there are two paths. The first one is native compile. That's the one we've used so far. So that's the path to a native binary image targeted for this particular CPU architecture. So you can either do that locally. So in that case, it will compile using the architecture of your own machine. But the goal is, just like we're having container images support in Spring Boot, where you can generate the Docker image locally or in cloud native build packs, the goal here is basically the same. You shouldn't really have to compile the image locally on your laptop, because production is probably, hopefully, not your laptop. So what you want to do is get the image compiled in a build pack and somewhere along the line in your CI, and then it's going to be deployed in production. The other path is the AOT optimized jar. So that's the regular jar plus all the AOT sources and resources that we contributed. And from there, you can start your application, but with the shortcut mode, where all the configuration parsing, add configuration, and so on, and setting up the bean factory. We've done all that already at build time, so you can just jump straight through to the bean factory being ready and getting those beans instantiated and get your app running.
So this is a summary of what we do on the Spring side based on what native image does. So as Brian has said, during the build time processing, where you see the banner, we actually refresh the context, but in a special mode, refresh for AOT processing, and that will evaluate conditions, parse configuration classes, look if import statements needs to be import beans, needs to be honored, and additional configuration classes need to be processed. So all that's done, we get is a view of the bean factory in terms of bean definitions. And then the engine uses that. One implementation of the AOT engine is to turn that into the code that you've seen. There's also the invocation of the runtime hints. There's also invocation of custom processors. So we have a few at the moment. And as we've explained on the keynote, the next feature release is about expanding those optimizations. Once you have that, you essentially have the same app, except one step has been pre-processed, and so set in stone, essentially. And then you can run it, you can pass it to the native image compiler. So one thing to mention about the static analysis, and especially the breadth of what Spring Boot supports. If we didn't do that and we just create a bunch of hints, as Brian explained, then we would be in a situation where the static analysis couldn't know for sure if you're using Cassandra, Redis, Mongo, whatever, because it doesn't have access to those conditions at build time. And so it would chip a lot of infrastructure. So also one reason why we're doing this is to tailor your application to the technology you're actually using.
So what we're going to share right now is our first version of a developer cookbook. So if you're starting, if you have a Spring application, if you want to go to native, what are the steps, what are the things to look into to make sure that it can work?
So the first step is to run your app in AOT mode on the GraalVM. So that's where the route where you take those constraints of processing the context at build time and you get the benefit of startup time. But doing that is also a way for you to validate that the AOT engine understood your application arrangement without going to native, waiting for the native compilation and seeing that it actually doesn't start. So it's really the first step, let's say. If that works, then you can go to the next step. If that doesn't, then you probably need to reach out to us because we messed up something.
So the second step is, so when you're working with native applications, you could be tempted to have a specific test suite and only perform real, full integration test with a live server and so on. When here, what we're trying to do is to reuse the existing test suite that you already have in your application. So it's still work in progress, but we're working towards having the test context report ready for AOT that would use the generated sources, and then you could compile with the JUnit report that's already there. You could compile all your test suite to native, and then those tests could be run in a native environment as a native binary. So that's a way to basically find all kinds of issues with missing reflection and what basically we showed. So if you're going through this step without finding any problem, you're in a very good place because you're almost sure that everything will be fine in native.
Unless you have zero test.
If you have zero test, it's not going to be fine anymore.
You have a different problem probably.
So with this, you'll probably find a different kind of problems, and that's where we can think about the next step.
So the next step is actually, okay, so there is some hints on a third-party library you're using, or your own code, or company starter, or whatever. And you want to contribute those hints, but also what you would like to be able to do is to validate that they actually match the use case you're targeting. So we've been working on a Java agent. We've been using that ourselves on a branch, where you can essentially define the hints. So in this case, those are hard-coded in the test, but that would be loading the ones you've contributed or call an implementation that you are testing, essentially, like the ones I was showing earlier. Yep. Then you have this recalled Lambda style, where everything that's in the Lambda is actually going to be processed by the agent. It will look for use of reflection, resource loading, JDK proxy, Java serialization, resource bundle, all that stuff that can be contributed by hints. And if that doesn't match, you get a test failure, essentially. So it's making sure that what you have contributed is actually fixing the issue. And in the future, what we'd like also to do is the reverse. So you're actually contributing something that actually isn't necessary. Because it's really easy also to have those ins layering around. You have contributed it in the past, and the implementation has improved, and those are no longer necessary. So having a test failing to tell you that would be nice.
At this point, you might be thinking, I'll probably have to contribute reflection and so on and hints for everything under the sun, including a bunch of libraries like logging libraries and so on. So the good news is, first, a few libraries already contribute their own, so including Netty and Tomcat. But it's like the Java ecosystem is huge, and we can't wait for all the projects to keep up and have those hints declared. So what the GraalVM team is working on right now, and will announce soon, is a reachability metadata repository. So this is a repository where a bunch of hints for a bunch of Java libraries will be declared, so the community can contribute to it, and you can contribute JSON configuration files and test to validate them. And once it's there, it will be automatically fetched by the native build tools plugin. And looking at your class path and your dependencies, it will fetch the right metadata, so you don't have to figure everything out by yourself. So we are the Spring team, because we have quite a bit of experience with the Spring Native experimental project. We already have internally a bunch of hints for many libraries, and we're right now working with the GraalVM team and contributing those rules to the entire community, so that it will make things easier for everybody. So the good news is, once it's out, I encourage you to look for news from the GraalVM team. They'll share the details, and you can contribute all that metadata yourself for well-known Java libraries. That'll make things way easier.
So the last step is don't do it, but if you need to generate some code because you are a library developer, or again, working on a starter for a company and you're using some slightly odd arrangement, or perhaps you have some processing that you would like to optimize at build time, which would be a good reason to do that, then you can hook into the engine and generate additional source files and reference to them. So there's a complete API for that. That's really what M3 is all about, M3 and M4. And so generating code can be hard, right? You want to make sure that what you've generated is actually doing the right thing at runtime. So we've built a test compiler API, a test API, where essentially what you can do, you can give it a bunch of source files. The test compiler will compile them and give you a callback in a class loader where those compiled code is available. So the way we use it ourselves is we generate a bunch of files that represents the bean factory or a specific feature of the bean factory. Then we create a new bean factory. We apply it to it by getting the compiled instance. And then we validate that the state of the bean factory is what it's supposed to be. So we're not really talking in terms of code, but rather what the outcome of the code should be.
Yeah, and again, you don't have to generate all that code manually. We've got a bunch of infrastructure. So we're showing here the test infrastructure for this, but we've got a bunch of infrastructure for generating source code. We've repackaging ourselves Java Poet in Spring now. So this is how we're generating the source code. But again, in many cases, you shouldn't even have to do this, because even us internally, for some cases, we started with code generation thinking it'd be the best way to go, and then we tried the reflection way, and we found no particular performance, memory difference. So we went with the hints way because it's way simpler, it's easier to test, and code generation is always harder than other things.
So essentially, that's the summary. First, start by executing your app on the JVM. You will essentially, at this time, test the AOT engine. You may use a library that we haven't really looked at yet, so something on the portfolio that we haven't looked at yet, which had an arrangement with the bean factory that we don't support. So getting your feedback on that is really appreciated. Once you go that stage, it basically means that whatever has been processed by AOT will work in the same way. Then your next step is to actually check if native is able to understand the application as it has been post-processed at build time. That may need to create some hints, so we have an infrastructure to do that and testing support to do that. Hopefully, if this is a third-party library, you can contribute to the Reachability metadata repository hosted by the GraalVM team. And if you're a library developers and you want to optimize, you want to go to advanced use cases, we have code generation tools and testing as well.
And with the milestone that we released recently, we're at a point where we delivered all the solid infrastructure for everything, hints, code generation, and so on. So that's why today we showed only a command line runner. It's because right now we're working on a second step for the next milestone, which is significantly expanding the use cases and supported Spring libraries and projects for the next milestone.
So the message is this new generation. One of the purpose we've been focusing a lot on native, obviously, because that's the hardest. But we want to reuse all that work to also optimize the JVM use cases. JVM use case is really a top priority for us. So everything that we do in that area will also benefit the JVM.
Yeah, and of course we're still working and collaborating with the GraalVM team. Our goal and the GraalVM team's goal is for the Spring community to have their existing apps and be able to run them as a native image as easy as possible. And that's what we're working towards.
And so hopefully this new generation lets you unlock new spaces. You can, as we've explained on the keynote, you could actually here, you could compete with some use cases that you couldn't do before. There's like new use cases that you can achieve using those new tools, and we hope you like that.
And of course, we're not losing track of Project Leiden. That was where there was an announcement recently. So all the infrastructure and all the things we've got in mind with this new AOT infrastructure that we've built, we've got Project Leiden in mind, and our goal is to support it as soon as it's out and align with the technical decisions there.
All right, so we have
6 minutes.
6 minutes for questions. The repository over there, that's the simple demo using hints and whatnot if you want to try it out. If you want to try it out with Maven, you only need to enable a profile call native, so mvn-p-p native package will work.
Yeah.
Any
questions? I'm not seeing anything, so.
No.
Raise your hand if you have a question.
I have a question. Who has migrated to Java 17 yet? Okay. Who's still on Java 8? We won't be recording.
Okay, fine. So I guess that's it. All right, you can just reach out to us anytime. And oh yeah, first the roadmap. So the latest milestone that we released recently, as I said, it's got the basics, the basic infrastructure. And we're targeting GA releases by, the end of the year.
Yeah, please keep the feedback coming. That's really helpful. Thank you.
Yep, thank you.